So this is our polynomial long division video. We're working towards taking an expression like this and dividing it by an expression like that. This is going to help us ultimately solve polynomials by getting them into factored form first. Last week we reviewed factoring methods, and long division is good for when one of those methods don't work. So we don't have a factoring method for this, for example, but if we can divide it using polynomial long division, we're one step closer towards getting it into a factored form. So that's one reason why we're learning this today. And we're going to start with these three problems, just reviewing the basic division algorithm with integers. So here we have 15 divided by 3. I would set that up like this, and I would say that that is 5. This number here, 15, that's being divided, we call that the radicand. This 3 that we divided by is the divisor. And the 5 on top, that's the answer. That's called our quotient. And this was easily or evenly divisible. If I were to do 100 by 5, I would say 5 goes into 10 twice. In other words, 10 divided by 5 is 2, right? 10 divided by 5 is 2. And then I would say, all right, 2 times 5 is 10, and I would bring that down. I would subtract it off, get 0, and then bring down my next term, or my next digit, which is 0. And I would start all over again. 5 times 0 is 0, and then I'd be done there. Now, 37 by 3 is the first time that we have a remainder. So 37 divided by 3, I would say that 3 goes into 3 one time. 1 times 3 is 3. I would subtract that off and get 0. And then I would bring down the 7. I would say 3 goes into 7 two times. I would take that 2 times the 3, bring it down and get 6. I would subtract that off, and I would have a remainder of 1. Now, usually what we would do is write this, we often write it as a mixed number, 12 and 1/3. Now, what you might not remember is that there's an implied addition here, 12 plus 1/3. And so this is the format we're going to use to write our answers in the polynomial long division down here. It's your quotient, the 12, plus the remainder over the divisor. So keep that in mind when we get down here. And we're going to use this basic algorithm down here with the algebraic expressions. And there's 2 points we want to be sure we're watching out for. We want to make sure our polynomials are in descending order, which means that the powers of x go from the largest down to the smallest. And then make sure all powers from the largest down are accounted for. So if it's missing a power, you want to put a placeholder. We're going to talk about that here in example 2. Okay, so example 1. So whatever is written first is my radicand. So I'm going to put that here. And it's not missing any powers. I have x to the 2, x to the 1, and then no x's or x to the 0. So it's already in standard form. So minus 5x plus 8. My divisor goes on the outside. So I'm going to start by saying, how many times does x go into 2x squared? I take the first terms and I find their quotient, 2x squared divided by x. And that is going to be 2x. And just like here, when I had to say 5 goes into 10 twice and I lined the 2 up above the second digit in the 10, how that's going to look here is I'm going to take 2x and line it above the like terms in the radicand. So I'm going to line 2x up above the negative 5x. So then in this problem, what I did next was I did 2 times 5. I did the quotient times the divisor and brought it down. So here, that's going to be the 2x times the x plus 1, the whole thing, and then bring it down here. So I'm going to do 2x times the x plus 1. So that is 2x squared plus 2x. So then, like when I was up here, I brought that 10 down, and then I subtracted it. So here, I brought the 2x squared plus 2x down, and I need to subtract it, and I need to subtract that whole thing. So subtract that entire group. So I put it in parentheses. So what that means you're going to do is take the opposite sign of each one. So negative 2x squared is negative 2x squared cancels with the positive up top. So the negative 2x, so negative distributed to here is a negative 2x, with the negative 5x on top is a negative 7x. And then the next thing I do is bring down 8. So now this process starts all over again. And one thing you can do here in this negative out front, you can change it to a plus and then change your signs inside the parentheses. And then here's where the process starts all over again. I look at the first term here divided by the first term here. So negative 7x divided by x is negative 7. I line that up above the positive 8 because those are like terms. And then I'm going to take that negative 7 times the divisor. So times the x plus 1. So that is negative 7x minus 7. And I have to subtract off this entire row. Well, subtracting off is the same as adding the opposite, so I'm going to change this to plus and then add the opposite of these two things, so change their signs. So now the 7x's cancel, and the 8 plus 7 is 15. And I have no more terms to bring down, so that's how I know I'm done. So the 15 is my remainder, so I'm going to write my answer in this form. The quotient first, my quotient was the 2x minus 7, and then plus the remainder over the divisor. The remainder is 15, the divisor is x plus 1. And you could put 2x minus 7 in parentheses if you wanted to also. And then for this next problem, notice that it's missing an x squared. So if you're missing a degree, or if you're missing an exponent in the radicand, or you're missing an exponent in the divisor, either way, I always use a placeholder with a coefficient of 0. So let me explain that. So x minus 4 is my divisor, and the radicand is 2x to the 4 minus x cubed. I'm missing x squared, so I'm going to put a 0x squared, and then plus 5x, and then minus 8. So I start by doing 2x to the 4, so the first term here, 2x to the 4 divided by x is 2x cubed, and I'm going to line that up above my negative x cubed. So that times all of the divisor comes down here. So I'm going to do 2x cubed times the x minus 4. So that's 2x to the 4 minus 8x cubed. And I have to subtract that whole row, so that's the same as changing their signs. So the 2x to the 4's cancel, and then I have a negative 1x cubed, positive 8x cubed is 7x cubed. And then I bring down my next term. And I start all over again. I take this first term, 7x cubed, divided by that first term. So 7x cubed divided by x is 7x squared. I line that up over my 0x squared. And now I do 7x squared times my divisor, the x minus 4. So that is 7x cubed minus 28x squared. And I have to subtract off that entire row. In other words, I'm adding the opposite. So add the opposite makes this a negative and makes this one a positive. So the 7x cubes cancel, and then I have 0. Positive 28 is a positive 28x squared. Bring down the 5x. Oh, I'm running out of room here. All right, so now I do 28x squared divided by x. And I get 28x. That lines up above the 5x. 28x times the x minus 4. That gives me 28x squared minus, so 28 times a negative 4 is negative 112x. I'm going to subtract that off, so minus that entire row. So that's going to be add the opposite, so plus negative here, and then changes this one to a plus. So the first terms cancel, and then positive 5, positive 112 is a positive 117x. Bring down your next term is negative 8. Last time, 117x divided by x is 117. That lines up above the negative 8. Oh my goodness. 6 years later, 117 times the x minus 4 is going to be 117x minus 468. You're going to subtract that row, so minus everything there. That's going to be a plus. Change the sign here, change the sign here. So 117x's cancel, and negative 8 and 468 is a positive 460. That is your remainder. So you've got your quotient up here plus the remainder over the divisor, which was x minus 4. And there you go.